All right, it's time to go. Let's get it. Yeah, it makes sense that the copy constructor would be the governing body for copy semantics. Yeah. In meaning that these would be different. Oh, fuck. Hold on. Meaning that these two examples would be different types of copy semantics. What do we want here? I mean, because these are just copies in general, but we could say... Yeah, sure. Yeah, that'll work. Sure, we'll do it for now. We'll do a class. Sure, it has a default, but it also has... Can I... I'm not sure how I have a check to make sure that it's only 3. I want an X, Y, and a Z. Whatever, it's close enough. Fuck, we can't do copy. Oh, but I guess I could do... Can I do it this way? Maybe. Maybe, I don't know if I can. I wanted to do... The fuck am I doing? Jesus Christ. Like, this is one way. I mean, we could do literally copy assignment to assign the value of vector to M location. So this is really copy initialization. But I wanted to do it member-wise. To say that, oh, the 0 index for vector goes to the 0 of location, etc. Or... Can I just initialize it to be the whole thing? Is that a thing that I can do? Why is the music not fucking looping? Why is it not an autoplay? I don't understand. Oh. I mean, that's it? Like, surely it would be in playback. Fuck off. Whatever. Oh my fucking god. Okay. Stupid people. Alright. What if we just do... and we just initialize it with vector? Can we do that? Why do you want a semicolon? This is a... well... I mean, it's supposed to be a member... a member list initializer. Or initializer list, sorry. I mean, what if I specified an index? No? It still doesn't want it? Honestly, I don't know. But it seems like if we're able to use a member list initializer list, it would be a different type of copy semantic, maybe, than initializing it in the body. Because this is a default copy constructor. Oh yeah, if we don't even... well, standard vector already has its own. The problem here is we have this own class. I don't know how to do it for... so standard vector has its own implementation for... it has its own copy constructor, but if I'm doing my own class, I'm surprised I can't just initialize it like that. Because it should then copy the copy constructor. Like this would be copying, or it would be calling vectors copy constructor, the standard vectors copy constructor. Yeah, I'm not sure why. I guess you can't do it. Syntax is different somehow. I'm not sure. Yeah, we return this and copy it here. And then it dies because it's just copied here and it's still gone. So we would need to have a separate array initialized with this. And if we create a temporary here, then somewhere in memory is instantiated with this, or well, I guess initialized with this value, but it's instantiated, sectioned off, and then initialized with this value. Excuse me. And then we copy that, this value here, but then this value just dies and we can't use it. Which means we're copying this value once to here and then copying it again here. Makes sense? Yeah, it's an R value. Yep. So the point here is we're saying that I feel like we're speaking in a long-winded way, but maybe not. I'm just a tard. The point here is we want a standard vector from generate. The problem is we are sectioning off a piece of memory and initializing it with value. And we want to use that value. But if we want to use it in main and reference it over time, we have to create another object and initialize it with this return value. It would be nice if instead we could just create that value here in one go and boom, we're good. Instead of creating, like, instead of assigning the value here and then assigning it here again, we should just put it here. But we want to do it through a function call. We're not going to, I mean, one way is just to fucking initialize it here. But if we don't know that, let's say this is a random value. We want the random values to just be put here. Boom. One assignment, that's it. One initialization, that's all. Not the random values are obtained, initialized here, and then we're copying that thing here, so it's 2 assignments. We want 1. And even if we say, if we do this and we return it by reference, it's still the same thing. We're still copying the values over. Excuse me. Meaning, create the original data and copy it here and then destroy it. It's not creating and keeping and copying, and now we have 2 sets, like here. Creating, keeping, copying, keeping. We have both. Boom, boom. But now we're creating, copying, and then destroying, and then we only have one set. So if we only want one set, we may as well only have one set, not create one, copy it, and then destroy the other. Why not just create one and then use that? The problem is that we have to copy it to store it again, to store it permanently in main. Okay. Move semantics. This is the part that I read right before sleeping. Yeah, ownership of data is transferred from one object to another. It seems like if we pretend that, well, yeah, I mean, If the compiler is aware of identifiers, then it would be nice if we could just say, hey, the little block of memory representing these values called array1 is now array2, and array1 is gone. And now referring to array2 actually refers to here. So we could just initialize this as the stolen value here instead of copying it. When ownership of data is transferred from one object to another, we say the data has been moved. What in the fuck? So the data has been moved from one or under, well, the ownership of one to another. The data hasn't moved, but it almost seems like the owner has been moved. But I guess really it's just saying that, like, we have a warehouse of gold and Jimmy owns it. But then the next day, he gives ownership to someone else who owns it, and now he owns it. The gold's still where the gold was, but its ownership was moved. So the gold has been moved from him to him. Two or three pointer assignments. Because it seems like that's how objects themselves even work. Like an object is just a pointer to a specific address in memory. And it refers to it. So if we have a pointer, we're really pointing to something that is referring to a place in memory. And so we're changing through the pointer, through the object the pointer's pointing to, that place in memory. Because an identifier just refers to something. Well, what does a pointer do? It just refers to a named object. That's it. And an L value is basically just a value that a pointer is persistently pointing to. But with the pointer being an identifier in this case. And so the point is we're moving it under, and then what do we say happens to the named object in the beginning? Or do we just not name it at all? Like if we have x and y and we move x's value to y, or we initialize y with the moved value from x, what happens to x? Can I use it? What is its value? What is its value? Is it now undefined because we don't know what it's pointing to, or what? Move semantics of the how data can be moved from one object to another. Maybe it differs by type or by, yeah, I guess type. You can say whether it's an array or not. Maybe it probably differs. So if we move an object under another object, any of that object, assuming it's a class object, the class object's data members are moved under, if they can be, and otherwise they're copied. Move semantics versus copy semantics. Some data members from one object to another instead. Data members that can't be moved. I wonder what makes them movable versus not. Like, I don't know. Please. Eyelash, am I? Bro, please. These fucking allergies, man. Oh, I'm just pissed off. My stomach is still messed up. It was hurting so bad earlier, so I had to eat, and now I have to eat again soon. I'll probably do it in 10 minutes. So is there like a type of copy elision where it sees, oh, hey, this copy isn't needed, and then boom, move semantics goes? So is it something where it checks that is A being created, B being initialized with A, and then A being destroyed? If so, just create A, move the stuff from A, and then A is gone. There's no copying part. Because the copy part is the expensive part, and the destroying part is also another cost in there. If the type, okay, so it is type supported, type specific, whether it can be moved or not. If the object is being initialized with a temporary of the same type, meaning that, hey, there's a value that's going to be destroyed that's being used to initialize or assign to something else. And the move isn't being elided, meaning that something else isn't preventing it from being moved. Standard vector and standard string both do move semantics, okay? Move capable. Standard vector and standard string. If it returns an R value, then it's can be moved. I'm curious about when, though. Is it like a const expression thing where other criteria have to be satisfied and we have to check? Because, I mean, I guess if we know that the type supports it, check. If it's a temporary, check. I'm not sure if we're able to know whether the move is elided or not. Passed by const reference, but returned by value. And the reason is because we aren't passing we aren't initializing with a temporary, we're initializing with the value from a non-temporary. So this part would not be true for passing, but returning it would be. Shouldn't be passed, but if they're move capable, they can be returned. When the passed values are class types, we have different steps. Construct the value to be passed. Okay, so we say, all right, I created a standard string to be passed. Then we are passing it to the function. Constructing the value to be returned. Hold. I may take this slower. Object exists, passing value to function, creating object to be returned, returning back. So there's value creation, passing, returning. Value created. V1's 0 being passed. Is that how that works, really? Oh, it's because this is returning a standard vector, we're accessing this. Okay, so passing here, creating the value, well, oh, wouldn't that also just be here too? This would be both steps. I mean, this would just be constructing value constructed to be passed, value passed. Wouldn't this part, when this is initialized, also be the same? Well, I guess not. If well, this is by value, but all right. I guess another example. Value created to be passed, actual passing. Excuse me. Standard vector isn't move capable. Construct the value to be passed. Hold on. Yeah, because we were copying this value into here to initialize this guy. We're then copying the value into the parameter. We're then copying the value from the parameter into v3. And then returning another copy to, and then copying back. So it's copying to him, copying to him, copying to him, copying to here as a temporary. I feel like this step can be omitted, but well, yeah, because that's just creating this anyways. We could optimize the second step where we are passing it here, so we could receive it by const reference and pass the object, receive it by const reference. 3, because this isn't a temporary, so this can't be moved. So this is the copy. But then this could be moved back. Makes sense, yeah, because we're creating a standard vector. Creating a standard vector owns this value, owns this value. But we could pass in this guy to be a reference, and then we could receive, well, could pass a reference back, but, well, no. We could move it back, though. So move it to be, instead of owned by v3, now it's owned by whatever else. Not sure how that part would work, because there's nothing. I'm not sure where it would be moved, though. We're just copying value from v1 into v2. Yeah, makes sense. And out isn't. And we're taking an L value to go to another L value. Oh, that's the point. The subsequent part would do that. So if we moved it to here, it would be lost. So if we were only doing this, cool, because we're returning the value as the result here. But we're printing v1 after 2. Nope, yep, because this guy's local, so it'd be dangling. If it realizes that we're taking a copy of this guy into this guy and then copying it here, maybe it avoids that copy and what, just moves from here to here maybe? I'm not sure. Meaning that instead of copying it here, we could just say this code gets replaced with standard vector v3, 0. So it's copied once here, but not copied here and then copied again. Instead of returning, it just already exists there. Yeah, it's weird because we're saying, okay, we have this parameter and we're setting it to be something, and then the function ends, all just to affect the reference of something. Oh, doesn't work with objects that we can't touch. So the reference of whatever we create would need to be a non-const reference, a modifiable one. So what we pass it an R value, so we pass it a const reference of a standard vector, but then we update a non-const one with that value? I guess so. It seems like that could work. It's temporary, it's supported, and I guess there's nothing else disallowing it. Leisure would be cool, but it's automatic. We don't know. And the next is to make it happen, basically. So instead of not creating something and copying it, we could just create it once here and that's it. Or we could create it and then move it, which is similar, but just the only additional cost is the move cost, which is apparently basically 0. For move capable types, we pass by const reference and return by value. Okay, makes sense. That's what you'd expect. Arrays and loops. I'm gonna try study and eat. Maybe it's a waste, but I'm gonna do it because I'm dying right now. Oh yeah. Meaning, how do we set or get each piece of an array? So if we have an array with all these indices, or if we have a class with 5 different data members, which is fine, okay, all right. We have a class, it's called hand. It has an unscoped enum inside it called card. And it has the different types of cards. Okay. But now we have, or better yet, we have deck. And deck has 52 cards. And each card is totally unique. I don't even know if that's how that works. I'm pretty sure, right? One of each card. Ignoring the jokers, I guess, so one joker maybe. Fuck, the sauce broke. I microwaved it too long. We may as well have a class called deck with one data member. And the data member is just an array of those cards with still an unscoped enum in the class. So how do we, like, get all the, I don't know, what do we even want to do? We want to dynamically update them. I mean, we could choose, like, the user puts in a number and we pass that number, or we convert that number to a static, or to a standard size t to index the array, and then we update that value with what the user wants. So the user says, hey, I want to update index 10 with, one array is this size so that we know it's valid. I want to update index 10 to be value 8. What if we want to keep on updating multiple ones every time? And we like loop through the index so that the user assigns value to each element. Could just have a loop going through the students in the class, and then we assign value each time the loop goes around. That way it allows us to determine, one, how many students are even in the class, how many we want to loop through, and we don't have to hard code any of it. Five students, okay. Oh yeah, instead of just having, excuse me, like a loop. This is what I did earlier. I think I made an example that was like this. And we took sum, and we loop through each piece, and we say, okay, the sum just adds this 0 plus this element because its value initialized to 0, adds this element, this one, this one, this one, this one, until whatever. And then now we can just divide it by 5, and boom. Instead of it being a sum, it's an average. And we didn't have to go in and print out something like that. And then we could just print the sum. And that's it. We create one variable for the sum instead of having to have 5 different total things. Yeah. And instead of just going through the loop, assigning value to each student, and then to assign it, and then looping through to print the sum or average. Yeah, now I have to divide by 301. Yep. Yeah, it would still work, but the value would be a little high. Here it is. I've been tired of chicken Alfredo for a while, but so hungry that it's overriding that. Excuse me. Oh yeah, true. We could just do a standard size T for the index. So yeah, for like this example. Excuse me, turning off music for a second was a good idea. I'll take these off too. Not some dang tistic. Alright, let's get it. We could just do it all in here, sure. Because the size is 5, we want to go through index 4. Yep. Yep. Or could just do, could print them all. Or we could say, well, I mean, we would need this to be after, I guess, right? Yeah, just like before. So we could say, oh, whoops. We could do sum divided by the size. Or we could have another variable in there. Is there another way we could do it? Excuse me. There's different ways. It's fine. Okay, so now we have a vector instead, an array. Oh, because the values are ints, so we have to static cast it so that there's no... Okay. So I prefer to just have it in a separate thing, but you can do either way. Yeah, we don't give a shit about it. We just care about whether it's signed or unsigned. It has to be unsigned, at least for now. What was the other way I was going to do it? I'd almost rather have a sum and an average, though, because there'd be a period of time where the average isn't the average. Like, I mean, if you wanted the cleanest way, it'd probably just be... Well, I don't know. I'm trying to balance cleanliness and idiomaticism, where it's readable and easy to understand. Excuse me. Okay. Okay, and now we have int score sum. And we could do one more thing after. Okay, so we could say for a standard size t called index, while index is less than scores.size, increment index, score sum plus equals scores index, and then int average is initialized with score sum divided by scores.size. Or we could say, yeah, that's fine. And then what are you saying? Hold. Oh, whoops. I guess we have to do that too. How was I doing it before? Did I static cast it really? I mean, there's one way. We have scores. We have the score sum. And score sum needs to exist outside the loop, so it can't be a loop variable. And then we have an average to create, or an average initialize like that. Otherwise, we get an unsigned to signed issue. Okay. Same length as this program too. I'll take it. Sure, you could have length in there as well. Then you have to, yeah, you could do it either way. I kind of like the calls instead of having this extra variable there. Yeah, I don't think we need the extra variable there, to be honest. No. Oh. Oh, well, you can do it this way too. I don't like the average being the sum in this case. Traversal, we are traversing it. Makes sense that we also call it iteration. Templates. Oh yeah, because we could do it each way. So we could have a standard vector of t and a separate definitions created for it. And any of those types of vectors could be accessed by template function. Makes sense. Yeah, we could do it that way too. And we only need one type, that's fine. The point here is what? Returning the average? Yeah. Oh, the average of some type though. And it takes, sure. We could say we have a standard vector, whatever, a standard vector called x that has 190 or 88 and 73. But then we also have a standard vector y that has a, well, needs to work for these. It won't, I mean, standard string would be interesting, but Okay. And now we do the same shit. We need a t sum. Sum is plus equals vector of index. And then we can static cast to a t. Yeah, sure. And then we could take another t average, and it is equal to the sum divided by, right? Static cast from a size t to a t, vector size, and then return average. And then we could say calculate average x excuse me, oops. Cool, works for me. Oh, true. And this could actually be maybe. It can be constant expression because we're not using any runtime only shit. I think that's it though. And you could do this either way. Remove a line of code, add a line of code. It's the same length. I just decided to have two separate things, a sum and an average. Sum, this is an average. I remove this, but I add another variable. Either way. Yep. Oh, because we're doing plus equals on a type t, and we're doing dividing equals to get with an int. So it's something divisible by an int. Oh. Meaning if we do a call with an argument that doesn't fit. Okay. We pass a vector of a different type. Of a different element type. Well, I mean, we get a common type anyway, so it doesn't matter here. Yeah, also true. How did I do it? Did I cast it to a T? I did. I mean, the common type it's gonna deduce and get a double or a floating point type anyways. So now we could find something. We could say if this is this, nope. If this is this, nope. If this is this, yes, good. Return that. Increment, it is itself times 2. Oh, this is itself times 2, etc. This one save it here. This one save it here. This one save it here. Keep going. So that, oh, we could have, yeah, like I could have an array of no elements in a big array, and I could be saving the last element. I could be counting down to start another array. So that we end up flipping the array, and then I can assign the initial one to be the one we've created. Sorted one, or the reversed one. Yeah, because we need to be less than the size, not equal to. Makes sense. Well, it's not loop until, it's loop while less than. Or loop until this is not true. It's not loop until it's less than. You better fucking hope the index is less than the length. If you do less than or equal to the length, we're using less than length. We're using less than equal to the length. At some point, for one with size 5, you're going to use index of 5. And 5 equals 5. Okay, the loop will execute. It'll plug in 5 to the subscript. Well, guess what? 4 is your biggest index. Undefined behavior, bucko. Bump, bump, bump. Oh, shit. Oh. Write a short program that prints the elements of this vector to the screen using a loop. Okay. Just printing each one. For standard size t called index. While index is less than array.size, index gets incremented. Output array index. And then I think it wants comma space. No. Space. Boop. And then probably at the end. Sure. Oh, and at the end, if the array size is that, because otherwise it won't print anything. And if the array isn't blank, then we need an extra line. Okay. That makes sense. If it's empty, I would have seen 2. Okay. Print array. Function template. Okay. And if it's not empty, Boop. Okay. These aren't needed really. Okay, so input validation. Oh. Oh. So we get the value, we print the array, we search it. If it's in, return the index. If it's not, return an appropriate value. What, a standard optional? Or you could just say return 10, because 10's too big. Excuse me. Or well, excuse me, in this case we only have an array of length 8. So you could just do 9, but either way. Excuse me. So we pass that value to another, like a helper function maybe. So we call print array. And print array is void. But print array calls will hold. And then have another function template that searches. So search for value. Excuse me. Excuse me again, sorry. Okay. So we have the array, and we could call a function let's search and print array or something. And we could pass the array and pass or we just pass the array, and then it prompts the user for value with a while loop. And that's just a function that we could call, and it returns the value they chose. That's an integer. Yeah. And it's just called get user index or something. And then we could do search the array. We could pass the array as a const reference, And then, so we keep on just passing a reference of the reference. And then that one could search, and we'd also pass it for the value they're searching for. And it returns a standard optional of whether it was found in the array. And then our function can check the standard optional to see if it should return a value or not, or what it should print. And if it does, it'll print the array, and then it'll say, there it is. So they put in 5, it doesn't have a 5, and if it's not, then okay. So we have print array. We could do this with separate functions too. Print array, we could do int get array index, and it's a we need numeric limits, but not yet. We could say just while true, enter an integral value, or enter an integer, and then we have int user index, okay, and then we could say if not standard character input, so if it failed, input extraction failed, and we could say if standard character input dot EOF, then standard abort, kill the program because UF character entered. But if not, then we can call ignore line, or we could just put it in here, either way. I won't do that yet. Include limits. If it's not, then UF character not entered, just ignore, or just clear, reset and clear input. So we'll do standard character input dot clear, and then we'll do oh, if it's that clear, and then we'll do standard character input dot ignore, and we'll do standard numeric limits, a standard stream size max, okay, or until an inline, ignore or clear input buffer, sure, and then continue, get input again, and then we could say if extraneous characters entered, clear them. We could say if standard character input dot peak is not end line, so we've extracted. If it's not empty and there's extra stuff, then we could do the same thing. Sure, don't repeat yourself, I get it. Void ignore line. Okay, so we get that, and then at the end we return user index, return valid user index. Okay. All right, and then so we could get valid user index. So we could say int user index is get user or get what? Get array index. This is a shit name. Get user index. Print the array. Get valid user index. And then search array for user value. And we could say template type name t void, or we could say standard. Sure. I guess we could do this now. Optional. And we could say standard optional t and search array const standard vector t vector. Okay. And so we optionally return the value of the t. And actually, really, this should be returning. Is this taking two things? It's taking the value. So it also needs to take the value and t search value, and it returns, or it could just print it. Oh, actually, no, it returns the index, not the value. Oh, it's not get user index, it's get user value. Am I a fucking dumbass? Yes. Bro, please. Or int asks get user int, really. This is get user int. Get user int. Get user, whatever. Can't we just do like find and replace or something? User index. Excuse me, place. Replace with user int. Oh, oops. Well. Okay. Hold. It's fine. All right. And so this holds the index and the value. And so we're calling this with the value, and shouldn't this just print where it's found? And then do we want to do this in here? Oh, I don't know about that. Okay. Okay, so we could say if we don't find anything, we're returning nothing. But if we do find it, for standard standard size t index, while index is less than vector.size, increment index. We might be doing a couple things here. We'll check if, actually maybe not, if vector index equals or is equal to the search value, return index, right? return static cast to an int index. And these should technically continue, but I think I'll do this just in case. Okay. And so now we can call search, or we could say if search array, and we pass in array and user int, we could say if not found, then we could say value not found in array. Else, oh, actually we could say I guess we need to store it, huh? Maybe. Standard optional. Well, I don't want a fucking optional T here. Well, I mean, it really should be. I mean, we're always returning either nothing or an integer. I mean, it should just be returning an int, right? Seems like it's fine. Okay, so we could just say standard optional int called found index. It's initialized with this guy. And if not found index, it's not found. Else user int found at index found index, or found index dot value. Okay, so we'll say 3. Oops. Three is found at index 0, 1, 2, 3. How about 4? It's found at index 0. How about 9? Index 7, the last one. Okay. If there's one that's repeated, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're just missing 5, so there's no duplicate. But if it was a duplicate, then it wouldn't say which one it was found at. It would only say the first one it's found at. What's better? We could say we have the index. We could call one function to do it all, or what else are we doing? What are the instructions here? Okay, get the value, print the array, write a function template to search the array for the value, and if it's found, return the index. Otherwise, return an appropriate value. Well, there it is for standard optional. We just store it as a value so we can conditionally evaluate it here. And then, if the value was found, print that. If not, do that. I mean, this is fun. 2 sample runs. So, okay, here's some examples. So if we do D, nothing, what does he eventually choose? He eventually chooses 6. And 6 is found at index 1. And then if he does 5, 5 is not found in the array. Okay. What's another way? Oh, this could be, actually, I don't know if standard optional can be const expression. Okay, it can. Nice. Print array cannot. nor can get user int. Okay. What else? So we have ignore line. This is fine. Can't do anything with that. Get user int is cool. We can print the array. That's just printing an array of any type. There's searching an array. Oh my! Oh. Oh, I wasn't ready for that. I wasn't. Oh. Okay, I'll check for more improvements later.